The increasing demand for broadband wireless communication networks is continuously growing and is expected to have an explosive increase in the next decade. The limited availability of sub-6 GHz spectrum band has promoted the research community, industry, and the regulator to use the millimeter wave spectrum, where a vast amount of available raw bandwidth will provide multi-gigabit per second transmission throughputs to mobile devices for next generation 5G wireless system. It is necessary to have a good knowledge of the radio propagation channel characteristic across millimeter wave frequencies in order to conduct accurate and reliable 5G system design. My research is going to focus on MIMO characterization and modeling at millimeter wave bands for future communication in typical indoor environment with the focus on conference room use cases. In this context, my ESR specific project aims, firstly, performing multi-band short-term and long-term propagation measurement in typical indoor scenario with the focus on the ISM band in the 60 GHz frequency range. Secondly, deriving multipath propagation channel parameters for future millimeter wave system using multiple antennas. Thirdly, studying the effect of possible interference between millimeter wave radio links. Finally, studying the effect of human shadowing in the millimeter wave radio propagation channel at typical hotspot scenarios. The development of this project will be carried out mainly at Durham University in UK and Televic Conference Company in Belgium.
5G mobile radio networks in the millimeter wave band are expected to operate in a variety of scenarios. These include high data rate transmissions over point-to-point fixed links, such as between buildings and lamppost to lamppost. Point-to-area links can be further classified as a line of sight or long line of sight. An experimental setup to study the impacts of precipitation on fixed link for building-to-building transmissions is set up on Durham University roof. Since the impact of precipitation depends on the rainfall rate and the raindrop size, a high-performance disorimeter is set up to provide accurate information of the type of precipitation, rainfall rate, and the diameter of the raindrop size. To study the impact of rain on fixed links, the experimental setup consists of a direct link operating together on two frequency bands, 25-77 GHz K and E band, with their transmission and their reception for polarization measurements. The transmission can be set up either as a continuum wave for rain attenuation or wideband frequency modulated continuum wave for the estimation of narrow pulse distortion. The collected data are analyzed using the fast Fourier transform, and the signal peaks around the two frequencies of 4 and 12 MHz are selected. Preliminary measurements are presented which illustrate the impact of rain and snow on the received signal stream. The aim is to collect data from the testerometer and monitor the received signal streams over 1 to 2 years to generate the statistic for an appropriate model for 5G fixed links. The addressed aim of this research project is gathering as a research engineer between the academic research achievements. A PhD program in Durham University will be enrolled, and the industry feed by performing a high-quality research segment within WaveComBE industry partners, WaveComBE in Sweden.